Good morning. Hi, I'm Dave McAllister, and welcome to Scalyr's first online workshop for 2019. We're glad you could join us today. Our topic today is Kubernetes in 1 hour, giving you a chance to learn about the various pieces you need to get Kubernetes up and running. We'll also finish up with a brief discussion on how to monitor your newly orchestrated applications and environments. A couple of housekeeping items. If you have questions, please type them into the Q&A tab, and we'll attempt to answer them during or at the end of the workshop. Depending on the time, we may not get to all of them, so we'll follow up with answers after the session. And just to let you know, the best question of the day, as picked by Christian, will receive a Scalyr swag package, including a t-shirt. So, joining me today is Christian Meléndez, who's a cloud architect at Equinix. Christian is a technologist that started as a software developer and has more recently become a cloud architect focused on helping companies to implement continuous delivery pipelines. He is a wealth of knowledge on Kubernetes, on containers, on cloud, and on DevOps. Christian, you with us today?
Yeah,
Glad you could join us, Christian. I understand that you're halfway around the world from me in Madrid. I'm here in California. So we're looking forward to hearing about Kubernetes with you. And with that, let me turn it over to you.
Okay, cool. So hopefully you can see my screen. Automate some of the tasks that you usually do with traditional operations. Kubernetes is not something different in a way that you are gonna do something new with your infrastructure. It's just a matter of how you're gonna do your administration and operations for Kubernetes. So questions that you will have when you have containers at scale is where to host the containers, when to scale containers, or where to host the containers, how to run those containers, and how to monitor those containers. And more importantly, who's going to do it, right? So we're going to talk about a little bit of about Kubernetes and how Kubernetes could help us to do that administration. So let me start by introducing a concept that actually I would like to invite you to read more about. Bridget Krumhout. She works for Microsoft as an evangelist, as an developer advocate. And what I like from her talk is that she says that containers will not fix your broken culture, and in a sense that just because you would like to get better at deployments, you would like to have better, to improve the resiliency of your operations, of the systems, or of your services, doesn't mean that just by having containers, everything will get fixed, everything will be okay. Actually, in the contrary, you will have, if you don't understand the concepts, if you don't have a clear idea of why you are choosing containers and orchestrators, and especially in this case Kubernetes, you might end up doing things in a completely different way that they were created for. So let's be clear on this, that containers will not fix all your problems, especially culture problems. It won't fix the problem between developers and operators. So it applies the same for Kubernetes. So let's get started by starting to know why Kubernetes, what are some of the features that make Kubernetes cool and the preferred orchestrator for containers. So one of the things that is cool about Kubernetes is the service discovery, because you will have that built in. Almost, actually, all of these features that you can see here on my screen, you will have those features built in with Kubernetes. Things like service discovery, load balancing, schedule affinity, storage, self-healing, deployments built in, horizontal scaling, secrets configuration, and batch processing. It is going to be your orchestrator for your applications that you happen to have in a container. It is not necessarily to run your containers with Docker. You can run with other container engine, but I guess that you will see that what is common now to run is Kubernetes with Docker containers. So one of the things that we're going to talk about today is how it looks like to work with Kubernetes from a developer perspective. Because traditionally we start by taking a look to the Kubernetes architecture, what are the components. But to be honest, that if you are starting with Kubernetes, that could be a little bit overwhelming, especially if you are seeing all the plugins, all the terms, all the services that are out there, all the ecosystem. Actually, the Kubernetes ecosystem is growing a lot these days. So you could be, you could get a little bit overwhelmed by all of the things that Kubernetes does under the hood for orchestrating your application. So even though I would like to it is a good idea that you understand the inners of Kubernetes and how what are the technologies that Kubernetes is using under the hood to orchestrate your containers and your workloads. It is important that you also understand why you want to start using Kubernetes, how it's going to help you, and that's exactly what we're gonna do in this workshop and this webinar. So the Kubernetes architecture, it consists of, you will have a Kubernetes master, you will have ideally 3 clusters that are managing and orchestrating your workloads, and you will have your worker nodes, or what it's called also minions, where all the containers, all the applications will be hosted, and the Kubernetes master will be in charge of scheduling all the containers, all the workloads that you actually tell when you are actually calling the Kubernetes API to orchestrate the containers in the worker nodes that are healthy, that they have enough resources to run your workloads and your containers. So instead of you having to do that manually, you can just start using Kubernetes for that. And what I like about Kubernetes is that you can specify the desired state of those workloads, of those objects in YAML. It's not code, sadly, but I'm not gonna talk about if YAML is good or not, but it is what it is. And this is how you will interact with Kubernetes, and how you will define your infrastructure as code when working with this type of tools. So let's resume in this at this moment that Kubernetes only happens to have a lot of pieces that you need to put together to create something cool. So what are those pieces? We're gonna deep dive a little bit on those technologies and on those aspects and that terminology from Kubernetes that will help you actually to start understanding the inners or the basics of Kubernetes. Taking that from a developer perspective, we must say that everything is an object here in Kubernetes. That's how you will define everything here in Kubernetes. You interact with the API, you create objects, and those objects are represented with a desired state, which you will define. Kubernetes use database there. It uses etcd to store that state of the objects that you are gonna be deploying or hosting in the clusters that have the Kubernetes agent to run your application. You will use YAML, as I was saying before, to define these desired states of your objects, of your services, of your workloads. And remember that I presented to you an architecture diagram of how Kubernetes looks like. It tends to be a little bit complicated in a way that it has a lot of things that you will need to configure, install before you actually can use Kubernetes. Which, by the way, I would recommend you to start doing that after you start working with Kubernetes, understanding more the concepts. There's Kelsey Hightower published project in GitHub called Kubernetes the Hard Way, where you can practice how to configure, how to install Kubernetes, as it says, in the hard way. But if you are running in production, if you are hosting your applications in the cloud, you can start using the offering from cloud providers where they will offer you Kubernetes managed for you. You only have to create or configure your worker nodes to start using Kubernetes. And that's actually one of the practices that I will do today, where you can see how you can interact with these services, these managed services with the cloud providers. One important aspect of Kubernetes is that even though Kubernetes architectures is architecture is designed to be highly available. You don't need to worry about that if Kubernetes in some way is down, or you have a downtime in the scheduler, in the master control of Kubernetes. You don't have to worry about your application, because what you will lose actually will be just the ability to update the application, to update the state of the application. If something goes down inside the application, there's not going to be someone that could recreate those workloads, those containers, those spots for you, because Kubernetes will be dead. But that doesn't necessarily mean that your application will be down. So and also, as I was saying before, Kubernetes is highly its architecture is designed to have highly availability. So, for example, if a node goes down, you don't have to worry about starting to configure everything again. You can start using, for example, in AWS auto-scaling groups. You can use AMIs. You can use things like that. All of those tools and all those architectures that you are using right now could fit into a Kubernetes architecture. So, from a developer perspective, this might be even high to you. You don't have to worry about how the inners of Kubernetes, what are the inners of Kubernetes, but it is important that you understand that at least you that by default you will have a behavior of workloads with stateless. There are stateless architectures that you will be able to run actually locally in your machine, which that's pretty cool. You might not be able to replicate all of the behavior that you will have in a cloud provider, because the good thing about using a cloud provider with Kubernetes is that when you start using some services in some objects in Kubernetes, instead of using the native infrastructure there, you will start using the cloud services that cloud provider offers. So we're gonna talk a little bit more about that in a moment. So yeah, that's all the theory, all the talk that I have for you. From now on, we'll be going through to the console. I'm gonna show you how I have configured my my workstation to use Kubernetes locally, and how it looks like to work in a day-to-day with someone that is working with Kubernetes and that is orchestrating their applications with these orchestrators. So one of the first things that you will need to do is to install Kubernetes CLI, which is called kubectl, where it is actually, you can install that in Windows and Mac, in a Linux environment, of course. And in your workstation, I would recommend you, if you are just starting, if you are a developer that are going to be using Kubernetes, or you just want to play around and you don't want to configure initially Kubernetes, you can use Docker for Windows or Mac. That will bring Kubernetes, the latest version brings the Kubernetes installed there. You just have to enable it. We're going to take a look to that. Or if you prefer, you can have Docker plus Minikube install. There are other ways where you can install Kubernetes, but for me, those are the two most relevant that where you can start playing with Kubernetes. Also, if you don't want to install anything in your computer, there's actually a browser managed version of Kubernetes where you can play around with that. Obviously, it's limited. You don't have to. You won't have the ability to work that locally and things like that. And also in the cloud, the name of the offering for Kubernetes as a managed service are the names that you can see here. For example, for Google, you will have something like that is called EKE. For AWS, you have EKS, and for Azure, you have AKS. So those are the primary cloud providers that, for me, are offering the best experience for Kubernetes as a managed service. We're gonna take a look to how to create those environments in every cloud. I'm not gonna create those services and those clusters right now, because it will take a lot of time to wait for the clusters to come up live. But I'm gonna demonstrate how to actually deploy your application in those cloud providers where you can use Kubernetes. So, for example, for Google, you will create as simple as this, your managed cluster in Kubernetes. It is you can run these commands in your computer. You will need to have installed the G-Cloud CLI in your computer, or you can use the Cloud Shell in Kubernetes. Don't worry, all of these scripts that I have that I'm describing here, all of the things that I'm gonna that I actually use for this workshop are in my GitHub account, which I will share with you later in the chat, where you can take a look and practice this at home. So for Amazon EKS, for example, the procedure to create the cluster is still not that mature. It's a little bit complicated. You need to do a lot of things before. But if you would like to just give it a try, you can create the cluster by using an EKS controller or EKS cuddle that a partner from AWS created. And it is going to be as simple as that. You can create the cluster with just one command, and you can obviously you can update this command as you would like to create the cluster. It will take more time in this case because it will start creating the VPC and things like that. But again, it is just for if you are just giving it a try, if you are just playing around with Kubernetes in AWS, I think that's the best option for starting with Kubernetes in AWS. Lastly, we have Azure, where you can create a cluster as simple as this. It is quite similar to Google, where you just create the you will have again need to install the CLI of Azure in the station or in the workstation where you're running these commands, or you can use the Cloud Shell from Azure too. So as simple as that, you can create and have a running Kubernetes cluster ready to use in the cloud. So let me show you how it looks like, my workstation here, and the application that I'm gonna use here for demo purposes. So for example, I install here Docker for Mac, where you can see for example, let's take a look to the preferences. And you can see that it's enabled here Kubernetes, and you can see here that the Kubernetes is enabled. I'm not sure if you can see my screen.
Yes, we can see your screen fine, Christian.
Okay, cool. Okay, cool. So let me continue then. You have here your Kubernetes cluster, and you just have to enable this. It will take a little bit, some minutes maybe, and you will have Kubernetes running right away. It is as simple as that. That's what I said to you, and I recommended to you actually to start with Kubernetes by using Docker for Mac, because it is going to be transparent. It is going to be useful. There are going to be some limitations, of course, but you can start playing with Kubernetes right away. So let me close this, and let me show you the application that I'm gonna be using for the demo purposes. This is a simple Go application. It is exposing an HTTP endpoint, and what it's gonna print the IP address, the host name where it's running, and I did that on purpose because I want to show you how it looks like to run that locally in your workstation, how it looks like when you are running that in the cloud. So, for example, you will just need to do something like this. If you don't have Docker running, for example, you can use go run, and let me take a look here. Okay, you can use go run src main go, and that will start running. That will start running the application without Docker, and you can see here that it's gonna be working here. My application is running here. That's how you traditionally will use it. And for example, let's say that you will start using now Docker, and you can see that here's the Docker file defined, where it will create the image here. And you can do something like this, but start using Docker. So you can see that you can create the image by using the Docker build. I'm gonna tag it here with this, and I'm gonna use this as context. I'm sorry. And you can see here that is creating the application, that is creating the image. So you can just then run the application, and I'm gonna call it here API hello, and it's gonna be running detached. And I'm gonna map the port here to port 85 because it's running the other application. That in port 88 it was the other application running, and I didn't want to create any conflict in case I would like to test the application running locally versus in a Docker container. So you can see here that it's gonna be running here. Docker run API hello -d. Okay. So you can see here that that should be run. Oh, okay. I think that I have to remove the other container that I have running here. Yep, that was the problem. So you can see here that is not running. Well, anyway, I'm not gonna waste more time here, because the idea is that you can see how I can run that with Kubernetes locally, because that's actually how you will run it locally. So before we continue running the Kubernetes, talking about what are the concepts and the objects that you will have with Kubernetes, let's continue by talking with some of the concepts that you will need to understand with Kubernetes. So let's start with pods. The pods are the smallest compute unit that you will use in Kubernetes, and you can basically group one or more containers in it. You can apply some patterns for distributed systems like the sidecar pattern or things like that, where you can start running your application for different purposes together. So as long as you continue using one container for one application per container, you're not gonna break the rule or the norm for using Docker containers in a distributed way. Containers will share networking, storage, and can be co-scheduled when you have a container running in a pod. So this will be these boxes here that you can see here are the containers, and this is the pod concept or the pod object. This is how it's gonna be represented graphically, and I wanted to use this image so it was easier for you to understand that concept. So for example, this will be the Kubernetes node, where everything will be, where the kubelet agent will be running, and you will have Docker running, obviously, if you are using Docker as a container engine. And then you will have here your pods running. For this, for example, we have 2 containers running in the same pod. This will have 3 containers running in the same pod. And each pod will be assigned an IP address. So that is really important that you are clear on that, the way that you will, the other pods and the other objects inside Kubernetes will use that IP address. And this is gonna make more sense as long as we continue talking about how to use the Kubernetes. So let me show you how it looks like to work with pods in Kubernetes. We're gonna take a look to the YAML definition. We're gonna create a pod in Kubernetes, and we're gonna kill a pod just to demonstrate why it is important to use the other objects that we're gonna talk about. So, for example, I'm here in the terminal again, and I'm using VS Code in case you are wondering what I'm using, because I like that it has a terminal integrated here. So you can see here that I have my pod definition, and it is as simple as this. It's a YAML definition where you define the API version, the API version that is gonna use to interact with Kubernetes. You have the type of object or of the object that you will be using. In this case, is a pod, and you will have metadata here. You will name the pod as API Hello Pod, and you will assign here labels, which is it's an important concept, and you're gonna understand a little bit more as we can see the other objects, and as we start. This is gonna be more important when you start logging and taking a look to the logs in the application. Then you will define here the specs of the pod. You will have here the containers running, and you will have here the name of the container, the image that is gonna be using for that container, the ports, and just like that, you can see that I'm not running here anything. Oh well, actually, let me just clean this a little bit. Okay, so you can see here that I'm gonna be running with this clean, and the intention is because I would like to demonstrate how to create each of these objects that we're gonna take a look in Kubernetes. So you can see here that if I run here this command kubectl get pods or pod, it works, and there are no pods running. So I'm gonna clear here, and I'm gonna run this command, and I'm gonna run apply, and I'm gonna specify here the definition that I would like to create. So I will create here, and just with this same command, it is gonna create the pod here, and it's gonna be running. This same command will work in another place where I have Kubernetes install, meaning the cloud provider or things like that. So it is as simple as that. So now that I have my pod running, the problem is that if I run something like this, delete pod, and I say API hello pod, you can see that the object is deleted. And when you run the query to see where the pods running, you can see that no pods are running, which, well, that will be like as similar as running Docker run. The thing is that you will need to expose that pod in order to interact with the application that you have there, or you can start working with a shell command to interact with the pod, and it is pretty much like a container. It is pretty similar, and the commands are pretty similar. But this doesn't stop here, because this will be just if you want to run simple applications, which I don't think that's going to be your case. So let's continue talking about another object, because we already saw that pods are mortal. And to give immortality to pods, we will need to use something called deployments. Because with deployments, you will define how many pods do you need for your application. You will define the rules to how to scale the application. How are you going to be deploying? Meaning that if you would like to have the built-in experience with no downtime with canary releases and things like that. Or if you would like to use blue-green deployments and things like that. Of course, you can use other tools for that job. We're going to make your life easier. But what is important here is that Kubernetes will be in charge of maintaining the state of the definition of the state that you have with the deployment. So let's say that you have here the cluster, and you will have here your nodes of Kubernetes, and this is going to be the master. The master will be scheduling this, will be in charge of scheduling your application, your workloads, your containerized apps in those worker nodes. So this is how it looks like in a graphic manner at deployment. So your deployment will be here defined in the master control of Kubernetes, and that will tell Kubernetes, okay, Kubernetes, run this application with this type of pods, with these resources defined, with this specs that I'm gonna define here. So how do you define those aspects, those state? Again, you will use a YAML definition, and you will create a deployment in Kubernetes, and we're gonna actually create a kill a pod again. But what we'll see is that something different will happen. So let's take a look to this. Let's take a look first to the deployment definition. This is the simplest definition of a deployment. This is like the minimum that you will need to have to run a deployment in Kubernetes. Again, you will use the API version. You will define here the type of object that you are creating. Some metadata again here, where you will define the name, where you will have the labels here for your deployment. This is gonna be really important when you start working with Kubernetes, because it's gonna be easier to query the objects. Because remember, it is gonna be only objects in Kubernetes. So you will define here the replicas. This is gonna be the copies that you want for your workloads. I'm saying here that I would like to have 10 pods running at the same time. I can define here auto-scaling policies, how I can do those scale up or down task manually. But again, it is preferred to use these type of things. And we're gonna start. I'm not gonna start talking about selectors here and labels. Just take note that this is important. This is how deployments interact with pods. This is gonna say that to Kubernetes that we will need to use the pods that have the API hello app label, for example. You can use another things like marking with labels those pods that you create here with this app that is gonna match here. And again, this looks pretty similar to the pod definition that we had before, that we were taking a look before, and it is and the reason is because it's using actually pods to define the deployment. So you will see here that is again the same API hello. You will have the image definition for the container, for example, and the container port. So you will have here, for example, again, kubectl apply f, and I'm gonna say that use this file deployment definition, and you can see that the object is created. So when you start taking a look to this, you will see that I have more pods running. I have more. Actually, I have 10 pods running. But the difference is that if I run again the command, you can see that all the containers are running. If I remove this pod again, what will happen is that Kubernetes will recreate another container, because the definition says that it has to have 10 pods running, and it will say that, and it will notice that there's one pod missing, and it will create the another pod based on that definition that we had in the deployment object. So if I run kubectl get pods, you can see that this is the new pod that Kubernetes created, and it says 20 seconds H versus the others that I have that only have 50 seconds, but are running by only 50 seconds. So that's actually the difference, and that's how you will give immortality to your pods. We're almost near on how to actually deploy and start using our application, because remember, we're not exposing your pods. We cannot use the pods right now as they are right now outside the Kubernetes. And they are just running there, but nobody is using those containers. So let's take a moment to talk about services, because this is how using this type of objects is how you will expose the pods. They don't rely on IP addresses, because remember that when I kill the container, the pod previously, the thing is that you will lose that IP address from that pod, or to say it is not like a virtual machine, but if it's easier for you to think about with a pod as a virtual machine and Kubernetes as your cloud provider, for example, that's okay if you can get that idea better. So the idea is that you are not going to be relying on IP addresses. This is why I was saying before that with Kubernetes you have service discovery built in, because you don't need to worry about that. Kubernetes networking is not that different from the traditional way of managing working with networking, but it has some differences that you will need to be aware of. Just that. Services represent a load balancer, and how it works, a service is by using the labels and selectors that I was talking about previously. So that's how you will, in a way, register your pods to the services, and the services will start balancing the load, run robin load in a run robin way to the load to those pods. So you will have here, for example, again, you will have here the deployment, you will have here the service, and it's like a layer here where you can say that these pods, I don't care where they are hosting, where they are being hosted. I just want to use those pods, and it doesn't matter where they are, as long as Kubernetes can query those pods, they will be, in a way, registered to the service. So let's take a look again how it looks like a YAML definition of a service. We're gonna create a service in Kubernetes. We're gonna kill the pod, and then I'm gonna run the same commands on every cloud provider, so that you can take a look that I didn't have to change anything in my code when doing that. So let's take a look to the service definition here. And it's pretty simple. Again, it's just a YAML definition. You will have here the API version, you will have the kind service. Again, you will have a name, and you will have some specs. You will have here load balancer. We're not gonna deep dive on each of these objects. There are other types here, but let's stay with this one for now. A type load balancer, and the selector will be app API hello. This will be the key value label that we'll use. You can also use other labs, and that's actually the secret, not the secret, but that's how you could actually start using canary releases, blue-green deployments, and things like that. So labels are gonna be really powerful. You will define here the protocol that you will use for service, the port that is gonna be exposing, and the target port that the pods will be using for that matter. So let's take a look to how it runs again, that how to create that object. And again, it's the same command, kubectl apply -f, saying that the file, and I'm gonna define here the YAML definition, and I'm gonna create it. So you can see here, when I have the kubectl get service, you can see that the service is created, and it's a type load balancer. And this is the cluster IP. This is the IP address that pods will be using to interact with the service. And the external IP address is localhost. Why is localhost? Because it's running on my machine. So if I go here to localhost and I open the app like this, you can see that it's gonna be running. You can see that it start gonna be using this pod, and I can remove this pod again. Kubectl delete pod, delete pod, and I can run this, and it was deleted. So again, I already demonstrated that is gonna create a new pod, and you can see that it's gonna change here. It's gonna change the IP address. This is gonna be the IP address of the pod. So again, this is running, and I'm ready to run this in the cloud. So I'm gonna move here to, for example, in Google. This is how you will create the commands that you will use to create the cluster here are really simple. You can see that the cluster is here running. I can take a look to another things here, the type of worker nodes that it's using, the endpoint, the version of Kubernetes, and things like that. I'm not gonna demonstrate here right now the other options because I want to run this application again. So I already cloned this repository here, and I'm using the Cloud Shell, and I'm gonna run just again, apply F. And in this time, I'm not going to specify each object. I'm going to say run all the files and apply all the files that are in that folder. So I'm going to run this, and you will see that it will start creating those objects, every object that I just demonstrated locally. And when you run here, kubectl get all, for example, you can see that everything is run, that everything is already running. You can see here the deployment. You can see the replica sets, which is under the hood is what is using the deployment. You can see here the service. And what's different here is that you will see here an external IP pending. Why is that? The reason for that is because the version managed of Kubernetes is using the cloud, the services from the cloud. So it is creating a service load balancer from Google. So let's take a look again. So you can see that is still pending. While it finished creating, I'm gonna jump here to Azure. This is how it looks like in Azure. You can see here the logs. You can see which workloads are container and things like that. So I'm gonna reconnect here. And while it reconnects here, I'm gonna demonstrate how it looks like in AWS. And you can see here that I also have the code here running. I'm using Cloud9 in AWS. So I'm gonna just run here, apply Kubernetes. And again, you can see here the same command, the same type of commands, where everything is running. And in this case, I already have an external IP address, but it's gonna take some time to put the application in service. So I'm gonna take a look here, and I'm gonna open the folder, and I'm gonna run the same command again. Kubernetes apply -f. And you can see that I'm running the same command in different cloud providers, and Kubernetes will still working. And let's take a look to this. You can see here that again is running everything again. It's actually again the pending state, the IP address. And let's take a look here to the service. So you can see here that the external IP address that I have here, I can just run it here because it's using the port 80. You can see that it's still running. And you can see that it's gonna start doing round robin balancing. The IP address just changed here. You can define obviously another type of policies for balancing, or you can use another objects that we're gonna talk about maybe later that will help you to get something more specific for your load balancer. So again, this is gonna take a little bit, but I want to finish with other things that I wanted to share today. So Kubernetes, other things, maybe not. Maybe you will need to start with why. Why do you need to use Kubernetes? Do you want to have all the features that are making Kubernetes cool in your application? Do you need to? Do you need to start working migrating everything to Kubernetes? I would recommend you that you will start with a small project, but that is relevant for you. And it doesn't matter if you are hosting Kubernetes in the cloud provider or on premises or wherever. Kubernetes will help you, and Kubernetes also will help you in some way to have a multi-cloud environment. It's not gonna be as transparent as someone will say that, well, with Kubernetes you have multi-cloud now, and it's gonna be the key for avoid vendor lock-in. But it is gonna make your life easier. So don't force its adoption, because you will still need to learn about the good things and bad things. And for your workload, maybe Kubernetes is not mature, but for other workloads, Kubernetes is already mature. That will depend, and I think that's a different discussion for another day. But again, that's what I wanted to share with you. What's next? A few more concepts that we didn't talk about actually are volumes, namespaces, ingress, config maps, secrets, jobs, daemon sets, stateful sets, that I will recommend you to start taking a look to that. the ecosystem is constantly growing. You will have things to, instead of working with one YAML definition, you can use Helm charts, for example. You can start using Istio, Envoy, Rook, and etc. The learning resources that I can share with you are the official docs, of course. There are also some official tutorial examples. And if you are already an expert, or you are already in the way of using Kubernetes, I would recommend you to start listening to the Kubernetes podcast from Google. So I think that will be all for me. I will let you, Dave, to continue.
Thank you, Christian. And if you want to take a look over, we've got a number of questions that are showing up in the Q&A pod. So
okay.
With that, why don't you take a look at those, and let me see if I can get my side working here. So, there, desktop, share, and so we've been through a lot of this stuff today, and hopefully you've got an idea of what Kubernetes is capable of providing for you. Now, along the same lines, there is something that you have to keep in mind here. As Christian has pointed out to us, Kubernetes itself adds a huge number of new layers of infrastructure to your environment. From the Kubernetes orchestration itself, through minions, into pods, into containers, and into apps. So all of those different pieces all come into play inside of here. So what I'm going to do now is try to share some of the ideas that might be really useful for you to consider when you're looking at monitoring your Kubernetes environments that are not necessarily things that you would think of while putting it together. So very honestly, simple things. Kubernetes is a massive aid in abstraction, but abstractions make life simpler, but when it comes to problems and concerns, abstractions actually make life harder. So the more that you have to dig into it, the more difficult and the more tricks that you have to consider. So when, again, we're looking at this, orchestration is the new way of dealing with this. Orchestration is what organizes, and it changes how we do these things. But it can also lead to some new questions, like what does Kubernetes actually just do? And did I actually get those 10 pods that I asked for here? And bottom line, even though the apps will keep running, if Kubernetes itself stops running, you need to be aware of that because of your flexible environments. So, starting off, let's start by looking at this. Monitor and collect the logs at each level. It's not just the application level that you need to be able to monitor and watch here. By collecting all of this information together, it gives you a fighting chance of at least determining what a root cause of any problem is, especially when it comes to interactions between the layers of the infrastructure itself. So Kubernetes also is an orchestrated environment, therefore monitor the orchestration itself. Keep an eye on all those various layers. Each of those layers, for instance, and we'll see in a minute in the demo, produce their own series of information, their own series of logs, and their own series of tracing things. This is a very complex environment, even though it looks very simple. So keep that in mind when you're putting it together. Make your environment itself as simple as possible. In microservices, it's not, for instance, about how small a service is. It's about being the minimum service size to produce the required results here. And finally, just something to bring up for this, account for ephemeral containers. Kubernetes, as we saw in Christian's demo, can start and stop things all the time. And because of this, it's possible for you to miss events if they're not being actively recorded and saved. So keep in mind that transient events make life a little more interesting when we're trying to figure out what the cause is, particularly between the services and the infrastructures. So similarly, let's step into it and look at a quick demo. So what I've got here is a Kubernetes cluster, and hopefully everyone can see this. A Kubernetes cluster. This cluster is a single cluster. It has 23 hosts and it's currently recording 62 logs. And it is about 550 million log records at this point in time. But as you can see at the top, we have things that are labeled because when we get down to the way that Kubernetes starts looking at things, you can have very broad and very unique, politely putting it, addresses that happen inside of the URLs themselves. So by allowing these labels, we can group like services together, and we can look at like services. So this is actually a microservices-oriented demo called HipShop. And HipShop is a retail type of environment here. And it has ads, it has card services, currency service, but of course the big piece in this particular case is the front end. And the front end is, in this particular environment, 3 nodes wide. So with everything inside of here, if something goes wrong, we'd kind of like to look at it. So let's start by saying what's happening. And this is a very simple thing. Pod restarts. We heard about pods, and pods are part of the infrastructure that contain the containers and therefore contain the applications in here. And even though Kubernetes will attempt to keep the number of pods there, a pod constantly starting and stopping is not a good thing. So along with that, though, we can look and see there are lots of metrics that are just standard to here, between the standard things that you see inside of systems all the way down to, for instance, again, pod restarts. This is a simple environment. So if we look at this dashboard, we can see that we're having a number of pod restarts that are starting, just about every hour. And I can zoom into them. I can zoom into them. I could add an annotation to them. I could share them, post it to Slack. So I've got ways of being able to look at this. But really what I want to do is I just want to zoom into this and take a look at the logs that are inside of here. So now we've got it down to the log entries that are specific for the pod restarts that we've just seen. The pods, for instance, that log, if you remember again, the pod writes a log the same way that the application should be writing logs here. And the log itself is broken into multiple sets of elements. And inside of here, if you remember, Kubernetes doesn't do a great job of telling you where things are, just make sure that something is running. Down here, you can actually see what IP address you are running on in terms of servers. So you can always be aware of where things are running as well as what things are running. So you can look at this in the original log. In services, we have lots of different pieces. You can look at this in a threaded log and see what's happening around it to see if the impact is being caused by another thing. But honestly, I want to know why my pods aren't running correctly. So let's switch over and take a look at what the pod says about it. So the pod, this is the pod log. And if we look down here, we can see very cleanly that we've run into this unknown exception handling. And it has produced very nicely for us a stack trace. And that stack trace, if you link to it, can take you directly into the source code at the line, because that's what stack traces do. So when we start looking at those pieces together, we can see that it's very simple to go through and figure out where we are in logs and what the logs are doing for you inside of here. Logs give you the ultimate source of truth, and it'll let you get to the root cause problem as fast as possible. Make sure that you use labels to help group these things together. And finally, make sure that you are able to make things simple enough to keep your arms around the entire environment. So with that, let's open it up for questions. We've had a number of questions across here. And if we've got, let's see here, we've got about 5 minutes left. If we do not get to your question, if it is in the Q&A pod, we will respond back to you and make sure that we get an answer to you after the event. So first of all, Christian, thanks for it. But can we kick off and take a look at some of these questions here?
Yep, I already answered a few of them, but I think that I'm not gonna have time to answer all of them.
Not a chance.
So, in case anyone want to know more about Kubernetes, or we weren't able to answer your question, you can reach me at Twitter or LinkedIn or wherever, and we will be helping you, or we can. That will be also for topics for upcoming webinars or blog posting in the blog.
Right. Just to let you know, the last question that came in, can you link the GitHub to the sample code? Yes, we will be sharing that GitHub link. Christian has been trying to make sure that we've got access to that. Another question, is Scalyr an OpenShift competitor? No, Scalyr is actually a log search and log management product. Our connection into Kubernetes is that we are members of the Cloud Native Compute Foundation, where Kubernetes lives, and that we are bringing the speed and scale to which we are known into a Kubernetes environment where we're seeing more and more complexity appear in these log environments.
I guess that I will answer another question that says how two pods or containers can talk to each other if located on different node cluster and so on a different network. In that case, it will be like if they are in a different cluster or network, that will be a matter of how you traditionally will communicate between your services. You will expose your pods using a service, or you can expose them via an ingress controller, which that's where Istio and Envoy and things like that will fit in. So you will communicate between other application in that way. Another question that I think that is important here is how does performance in Kubernetes compare to non-Kubernetes deployments? Is there an overhead added with pods management? Well, yeah, of course. There's gonna be an overhead in a sense that you're gonna need a few seconds maybe to scale up the clusters or recreate the pods. Or in case you would like to scale up or down the node or the worker nodes, you will have obviously a little bit of a little downtime there. But it is actually, we can deep dive on this topic, but short answer, I will say no. It will actually be helping you to manage what you traditionally will be doing manually. And with Kubernetes, you will just need to take care about some of the real things that actually will cause problems, and you won't be paged again because you are running out of capacity because you're having an increase in the traffic. So that's the thing.
Okay, so to wrap up today, Christian, thank you so much. That was incredibly useful and informative. We really appreciate you taking part of your evening to share your depth of knowledge with us on Kubernetes.
Sure.
And next month, we'll be looking at sort of the DevOps side of the Kubernetes world with Chris Short, who is one of the CNCF ambassadors, Cloud Native Compute Foundation ambassadors, and is quite well versed in being a DevOps in this world. So with that, I'd like to thank you all for joining us today, and we hope to see you next month.